So, hello systems distributed. In 1970, Nikolaus Wirth releases the Pascal programming language, whose compiler was originally implemented for the mainframe owned by the Swiss Federal Institute of Technology in Zurich, where he was professor. Nikolaus was presumably interested in convincing other institutions to use Pascal, but to convince anybody to use your software, they first need to be able to run your software. Back then, software distribution was harder than today, not only because it was a good 20 years before the creation of the World Wide Web, but also because computers had varying architectures and capabilities, making it hard to share data, let alone programs. To solve this problem of software portability, Nikolaus worked closely with a graduate student to create a virtual machine that he called the P machine. With the benefit of our modern insight, we can understand his plan very clearly. Anybody interested in running Pascal would need to implement a P-machine interpreter for their specific computer, but once that was done, they would gain access to the Pascal compiler and pretty much all software written in Pascal. And in fact, in 1973, Nikolaus starts distributing the P-kit, a bundle containing Pascal source code for the P-machine interpreter and a copy of the Pascal compiler, itself already compiled for the P-machine. One interesting detail is that the P-machine source code was not meant to be compiled with the Pascal compiler, because that's what you were trying to bootstrap, but rather it was meant to be read by a human in order to implement manually the P-machine interpreter using whatever language the machine supported. Eventually, a P-kit found its way to the United States, where at the University of California, San Diego, Ken Bowles took it to the next level of adoption by building an entire OS around it called the P-system, which could run on personal computers such as the PDP-11 and later on the Apple II Plus. Pascal is one of the first programming languages to have gained widespread adoption, in part thanks to the fact that it targeted a virtual machine. Hi. My name is Loris Groh, and yes, I'm VP of Community at the Z Software Foundation, and what I just showed you is called a framing device in cinematography, since we are in a cinema. Just like a narrative device helps to move forward the story of a movie, a framing device is a storytelling tool that helps to put into focus the overarching themes that act as background for the main story. It's also not uncommon for framing devices to be a little bit confusing when you see them at first, because while they do help with the framing of the story, as a viewer, you don't know yet where the secondary story of the framing device wants to go. And usually, you only get to connect the dots at the end of the movie. And in fact, we're not going to talk about Pascal, nor the 70s. We're going to talk about static site generators in our contemporary times. Sorry for the jump. As a short aside, when I pitched this talk to Yoran, I was thinking of showcasing some concepts specific to systems programming, but after workshopping the talk a little more, we concluded that it was a better idea to focus on, the talk on why you might want to learn more about systems programming in the first place. Anyway, back to the main topic. For those of you who have never heard about static site generators, they're tools that take your content, some HTML template, and produce rendered HTML that can be hosted on GitHub pages, for example. The content is usually written in Markdown, although not always, and there are a few different template languages that you can choose from. Static site generators are really handy, and there's a lot of websites that don't need anything more than that. Personal blogs are the quintessential example, and the official Zig website is another example of a static website. So if you never use a static site generator, I actually recommend you give them a try. That said, static site generators can also be an interesting case study from a systems programming perspective. So about a month ago, I did a live coding stream where I wrote a basic static site generator in Python. If you factor out the time spent chatting with viewers and wasted in other Twitch streaming stuff, most of the time was spent shopping for dependencies, and then the coding part was less than half an hour. So in fact, the main structure of that Python static site generator that I wrote fits in a slide. So you start with the imports, of course, right? You grab two dependencies, front matter, markdown. If you don't know what the front matter is, I'll explain that in a second. Next, I need a templating library. So if it's Python and I need a templating library, anybody has any suggestion? Jinja, of course. That's also what I chose. And then after that, it's very simple, right? You scan the content directory that contains a bunch of markdown files, and then for each one of those, you load it. Loading means opening the file, reading it, and then parsing the front matter. So the front matter is the key value pairs, the metadata at the top of a markdown file. And then you also take the markdown content, so everything after the front matter, and you render that to HTML. Then, for each one of those pages that you loaded, you load the layout, where the corresponding layout is, you see that the front matter has a layout key. So the layout key points to a Jinja template somewhere in your hard drive, or whatever you decided to put it. You load that template, and then finally, you render the content by running the Jinja template and placing the markdown content rendered to HTML in the right place. So you can write one yourself, and it really doesn't take much. And yeah, what I'm showing you seems very standard and mundane, if you think about it. But to me, it was very strange, because I'm not used to doing software development that way anymore. And to explain what I mean, I need to come clean. And I need to tell you that I've been working on another static site generator written in Zig, and for close to 2 years now. It's called Zine. Like in magazine, or even better, in fanzine, for those of you who know what a fanzine is. Almost everything in Zine has been written from scratch, and I will show you now what I mean by that. But before I start, there's one important thing to keep in mind. I will now show you many of the design choices that I made and the ecosystem that I'm building around Zine. But my goal is not to sell you on my specific design. What I want you to appreciate as I narrate my experience is the plethora of interesting design questions that I got to answer by tackling site generation from first principles. So let's get started. And the first thing I looked into is the templating language. Most static site generators use a templating language like Jinja, that you all knew, and Mustache, for example, which I refer collectively as curly brace templating languages because they all tend to use curly braces. But I'm not a fan of curly brace templating languages because they treat HTML as plain text. They lose the structure of the HTML. They are unaware of it. And they allow you to express stuff like that is not wrong, but you agree it's not great either. And this is very tame. You can do much, much worse than this. The people that said Jinja before probably have stories to tell. Everybody has. And not only that, but they also, when you're editing these files, they break syntax highlighting, they break out indentation, they break code navigation. And so I decided to make my own templating language that would instead use element attributes to express logic. And this is what it looks like. Since my templating language is expressed as valid HTML, I first needed an HTML parser. And after considering a few existing implementations, I decided to write my own. Writing an HTML parser from scratch is maybe a bit tedious, but it's not too complicated. All you have to do is follow the spec. And there's one neat trick that you can do when you're doing this work, where basically you can copy-paste relevant bits from the spec next to the code that implements the corresponding section. I highly recommend it. It's nice. That said, in some cases, you might want to deviate from the spec. For example, in my case, I decided to be more strict than the HTML standard when it comes to closing tags. According to the standard, this HTML is valid. And it should be parsed as two siblings li elements, one containing foo and the second containing nothing. So this is basically what you should be interpreted as, with the closing tags left implicit. There are rules about this. It's not great, but it's not completely insane. But the problem is that, it's also very possible that if you're writing this HTML by hand, this might very well be a typo, right? You might be missing the closing slash, and now it's a different thing. And since in my case, since I'm in charge of writing the parser, and I'm writing a parser tailored to my static site generator, I chose to sacrifice full spec adherence to remove ambiguity and report this situation as an error. To be super clear, I'm doing this because I'm writing a parser for handwritten HTML, and I wouldn't have made the same choice if my parser was meant to be used by a browser, for example. Talking about errors, I wanted to give my users also feedback about syntax errors directly in their editor, something that you normally don't get from templating languages unless a JavaScript framework is involved. And maybe I should also add that if you're using something like Jinja, and the fact that you can template HTML regardless of its structure, it's kind of impossible to provide you with good diagnostics in that context, I think. So here you can see my LSP in action, complaining about a lot of things in Helix. Since my templating language is valid HTML, I started implementing a language server for HTML and discovered that before me, nobody had bothered writing a language server for HTML that reports syntax errors. Usually when I tell this to people, they don't believe me. And I, understandably, I didn't believe that either in the beginning. And I invite you, open VS Code, type some wrong HTML, close a tag that you never opened, close a span that you never opened. VS Code will not bat an eye. I wrote a blog post about this. And making the claim that it was the first. And the register picked it up, it got on Hacker News, nobody corrected me, so I think I'm right. And to be clear, you can get diagnostics for HTML. If you're using like an editor like WebStorm from JetBrains, you do get diagnostics. It's just that it's not a language server, it's not open source, it's proprietary to their editor. Now, if you want instead to get diagnostics in VS Code, you can download the Super HTML extension, and you can get those. And it's also now configured by default also in Helix. So if you have the Super HTML CLI tool, Helix will automatically pick it up and start complaining about your wrong HTML. Just one, to manage your expectations, the language server works, but it's very bare bones. It gives you diagnostics for wrong syntax, but it doesn't have all the other nice things that you would want to have from a language server. I will implement them eventually. They're just not there yet. So once the templating language was good enough to be used in Zine, I looked more into the content markup language. And my first iteration was vanilla Markdown with a JSON front matter, because I didn't want to write a YAML parser. But JSON is not a great language. YAML is the standard for this stuff. Sorry, it's not a great. JSON is not a great language for front matters. I should contextualize. YAML is the standard, but I don't like it. There's also TOML. I don't hate it, but I think that TOML is kind of overkill for the use case of a front matter. And so I looked into a few other languages. None of them really clicked for me. And so, you know what? I decided to make my own language. So I stole some syntax ideas from Zig, which is why I called it Ziggy. And I decided to tackle all the things that annoy me about JSON, which now I'm going to tell you all about. First of all, I have different syntax for key value objects that allow that follow a fixed schema versus dictionaries, where the user is also in control of key names. In this example, you can see where under extra, like do, sender, roles, extra, ID, time, payload, those are part of a fixed schema. But agent and OS, it's kind of like metadata, key value pairs. In this example, you can put there, and you decide what to put them. They don't follow a specific schema. So that's why, and they use strings as keys. They use different syntax than the other key value pairs. Then another thing that it did is add explicit syntax for tagged unions, because in JSON, there are a few different ways of expressing this kind of data structure, and none of them is good. I don't know if anybody here has ever felt the pain of trying to deal with tagged unions in JSON. I hate it. Then I created a schema language for Ziggy. And in my opinion, it has two critical advantages over JSON schema. The first one is that it is not expressed as a Ziggy document. It has its own separate syntax, as is the case with JSON schema, because JSON schemas are JSON documents, and I personally consider them unreadable by humans. And also, most importantly, the Ziggy schema language is less powerful than JSON schema. For example, in JSON schema, you can describe schemas where an object has some fields that are mandatory, some are optional, and maybe some others are up to the user. But maybe they need to match a regular expression, and like you can put the regular expression in the JSON schema. And I'm convinced that this flexibility just leads to bad API design. I think there are config files and REST APIs that are like way too complicated, partially because of that. Another thing that annoys me about JSON is that there is no standard CLI tooling. So I made one. I made a single executable that gives you formatting, querying, schema checking, format conversion, and of course, a language server. Writing a language server for Ziggy turned out to be significantly harder than the one for HTML. And it really drove home the point that you really want multiple parsers for the same language, each tailored to your specific use case. More specifically, a language server has to deal primarily with incomplete syntax, and the Ziggy parser used by the language server is a resilient parser based on ideas explained in this blog post by Mattclad, who is the creator of Rust Analyzer and who's going to be our next speaker. So thank you. There's one last neat thing that I did with Ziggy. So if your top-level element in the document is a struct, you can omit the outer curlies and reclaim one indentation level, which in my opinion makes it a pretty decent language for configuration and front matter data. To conclude this section on Ziggy, just be aware that while I'm serious about this project, just like I'm serious about the rest of Zine, and have been for the last 2 years, Ziggy is the most work-in-progress part of the ecosystem. I still have to do design work on the schema language. The CLI tool is not fully implemented yet. So if you want to use it, you will have to participate in the development process. OK, so after taking care of the front matter, I was left with the Markdown content. And I mean, Markdown is fine, right? There's no need to reinvent it, right? OK, there's one thing that drives me nuts about Markdown. It's a use case that I had multiple times, and every single time I felt that Markdown fell way too short on it. Say that you have a document with 2 paragraphs, and you want to render them as a 2-column layout. Probably you had to do this yourself. Maybe not this specific case, but you want to render part of your document in a non-linear layout. You want to do something special. And it's always a problem, because what you end up doing in all these cases, so here you can see how you do it in Hugo, how you do it in Common Mark with inline HTML, MDX, of course, importing from LeftPad incorporated, as one does. And what I find it horrible, especially in the Common Mark case where you put inline HTML, is that the whole reason why you were writing Markdown in the first place is because you didn't want to write HTML when crafting content. And now you're pulling HTML into your Markdown. And so you're basically defeating the whole purpose of coming up with this separation of concerns. So let me show you how I do it in Zine. In Zine, I basically extended Markdown. I have a normal Markdown parser, and then I analyze the Markdown AST, and I guess apply transformations to it. And the way it works is that I basically have this concept of sections where you can split your Markdown file into multiple sections. Each section has an ID. And then in the layout, you can render specific sections. This works also because another thing that I've noticed from other static-side generators that I've used is that usually they pre-render all of Markdown to HTML, and then they only allow you to put the entirety of the Markdown document just in one place in your template. Well, in my case, I keep around the Markdown AST, and in the case of section here, for example, I allow you to only render subsections of it on demand based on your needs. I also made more changes to Markdown, but I'll spare you the rest. And instead, I'll give you what I think everybody is more interested in, benchmarks. So I wrote a bunch of parsers and interpreters myself. Let's see how I fare against other SSGs, other static-side generators. The Python one that I made by gluing dependencies together takes 375 milliseconds to render my personal blog, which is about like 40 content pages, more or less. Hugo, written in Go, and it's very popular. By the way, raise your hand if you use Hugo. Oh, there's a few hands. Yeah, I like Hugo. Zine is in good part also inspired by Hugo. Hugo takes 61 milliseconds, much, much better. Zine takes 7 milliseconds. But it wasn't 7 milliseconds since the beginning. I did a little bit of work to improve performance, nothing crazy. But for example, one thing that I did was instead of rendering pages sequentially, I rendered them in parallel, because rendering pages at that stage, there's no data dependency between the different pages. And so there's no reason not to render them in parallel. And what's funny is that when I did that, I started getting weird outputs. Some parts of the rendering would break. And it turns out that the parser that I'm using Markdown, I'm using CMark GFM. So it's a fork of the most commonly used Markdown parser that implements the GitHub-flavored Markdown extensions. So, and it's owned by GitHub and maintained by GitHub. And what I discovered is that basically, the people that implemented these extensions to the parser decided to use global variables to store data that belongs to an individual AST. And so if you parse multiple files at the same time, they all clobber the same global variables. And it made me think, what the heck is going on at GitHub? I don't have an answer. I don't know. But this is the state of things. And so I forked it. I have like a fork on my account. And in my case, the fix, it was good enough to just make those global variables thread locals, because in my case, I have one parser per thread. But interestingly, this is not even fully correct. It's correct enough for me. But if you are using a Markdown parser in an even more general purpose way, this is still going to break. And now you might be thinking, wait, what about so the Python one is not doing great. Did you bother trying to render pages in parallel? Which is a good question. And I'll show you what happened when I tried. And so no, I'm rendering them sequentially in this case. I'll show you what happened when I tried to render them in parallel. It went from 300 milliseconds to 661. Does anybody know why? Care to guess? Yeah, the global interpreter lock, of course. Good point. But they got rid of that, right? So you can get a Python interpreter, a C Python interpreter, without the global interpreter lock. And I did it, and it takes only 500 milliseconds. Why? I have no idea. It's too complicated, honestly, and I don't want to become a C Python expert. And so I just left it at that. Unfortunate, but it is what it is. OK, so back to Zine, back to my Zig static site generator. Another dependency that I have in Zine, and by the way, Zine is almost entirely written by myself from scratch. CMark, the Markdown parser, and what I'm going to show you now are pretty much the only two big external dependencies that I have. The other one being Treesitter. Treesitter is a parser generator library. It's used by text editors, for example, to give you syntax highlighting. It's very nice because it's basically one framework where everybody can create a grammar, a Treesitter grammar for their specific language, and then you can basically port syntax highlighting to a bunch of different editors and tools very easily. It's also relatively efficient, as far as I can tell, so it's fast. But it has one very weird quirk. It is very slow at parsing queries. So when you do syntax highlighting for a language, when it comes to Treesitter, you have two pieces that you have to care about. One is the parser itself, which it's basically C code that gets compiled to native machine code, and that usually runs fine, as far as I can tell. And then there's a second part, which is a tiny file that usually has like 10, 20 lines of Lispy expressions in it. They're not very complicated. And those are the queries that get used to do syntax highlighting. So they tell you basically, well, they tell the editor what is a keyword, what is a Boolean, what is a string. And so then your editor can apply the corresponding syntax highlighting. For some reason, loading these queries takes, I believe, 10 to 15 milliseconds, which is weird, because loading one 10-line file takes twice as long as rendering an entire website. So clearly something is not going right in that process. And I think there's also other static site generators that decided to not use Treesitter for syntax highlighting because of this problem. In my case, what I did, or rather, what Neurosite did, who is a member of the Z community who is working on a text editor, a TUI text editor called Flow in Zig. We share the package that contains Treesitter plus all the grammars, because he needs to do syntax highlighting in the editor. I need to do that for your code snippets on your website, because Zine provides you with build time syntax highlighting. So there's no need for a JSON library to do the syntax highlighting at runtime. We do it only once when building a website. And what he did basically was enhance the build pipeline so that we would basically load these query files using Treesitter at build time, and then we serialize the in-memory data structure in the final executable, and then once Zine is running, like at runtime when you're using it, then it doesn't need anymore to load any file, because it can just rehydrate the data from memory. This is also another reason why now Zine takes only 7 milliseconds. There's a lot of more performance work that I haven't done on Zine. And I think that I could probably even go sub 5 milliseconds if I put some effort into it. The thing is, it's a big ecosystem. I only have 2 hands. And so I decided to, like, performance is already good enough. And so I will prioritize other stuff first. Last interesting tidbit on the topic of performance before I move more towards the final conclusions is that this experience also was interesting for me because when I was only programming with higher level programming languages in the past, there was always this concept that whenever you're doing something that isn't trivial, it's always a good idea to have a system that allows you to do partial rebuilds, where basically instead of redoing the work every single time, you diff what you have versus what changed, and you only do the minimal work to apply the diff. What's interesting in this case is that Zine today is so fast that I have a web server with library load. So you run the Zine dev server locally on your computer, and every time you change something, it immediately rebuilds and reloads the page in your browser. But it's so fast that I don't need that. Eventually, I will need it because you can always come up with a website that is big and complicated enough that doing partial rebuilds is necessary. But it was very interesting for me how far you can get when your basic infrastructure is that efficient. So let me get to basically my recommendations and kind of tie back to what I'm trying to say with this talk. Because again, my point is not to sell you on my static site generator. And the point is that even if you hated every single decision that I made, the point is that I got to answer all those interesting questions. And you know what? Especially if you hated them, then you should do the same and answer them with the way that you like and provide a great static site generator for people that have different sensibilities than mine. So how do you do that? Well, if you never reinvented the wheel, there is nothing wrong with depending on other people's code. But there is something wrong if depending on other people's code is the only thing that you know how to do. Every dependency that you pick up is a piece of user experience that you don't get to design. This is especially harmful when it comes to core components of your program, because you will cut yourself off from the design questions that will allow you to push forward the state of the art. Additionally, every dependency that you take on is a chunk of technical debt. It's code that you don't fully understand because you didn't write it yourself. And in my case with Zine, I only have 2 dependencies that I just showed you. They're both very prominent projects that you would think you should be able to trust blindly, and yet each had significant issues that needed to be worked around. Reworking your relationship with dependencies is the first step towards understanding systems thinking. That doesn't mean avoiding dependencies entirely, but it does mean understanding fully the trade-off that you're accepting. And interestingly, once you free yourself from the need to use dependencies, that's also when you become more effective at using dependencies. Earlier, I mentioned that choosing dependencies for my Python static site generator was weird. And that's because I was purposely doing it on stream by looking at GitHub stars and other vanity metrics, which is the only thing that you can do if you never reinvented the wheel. In my Zig journey, I learned to stop looking at dependencies as black boxes and instead to treat them as code that I'm willing to eventually become the maintainer of or replace entirely. And that means that when I'm shopping for dependencies, instead of looking at vanity metrics, I read the source code that I know I will have eventually to maintain or replace. If you only ever use high-level languages, there is absolutely nothing wrong with using a language because you like it. And there is nothing wrong with getting more mileage out of a language that you already know, even if it's not the best tool for a specific job. That said, I think we are at a point in the history of our industry where we need to also rethink our approach to programming languages, which finally brings me back to the Pascal story. At the beginning of this talk, I mentioned how targeting a virtual machine was an important part of Pascal's success as a language. And in my opinion, one of the most effective ways of using virtualization is to bridge gaps in software distribution and portability. Python, JavaScript, Ruby, Java, C#. These are all popular languages that target a virtual machine. Do we use those languages because of that? The answer is almost always no. Developers don't even know or care about this fact, the fact that they target a virtual machine most of the time, in my experience. And ironically, software written in those languages is harder to distribute than software written in a compiled language that can target all the required platforms. Andrew made this point already in his talk at the last Systems Distributed, but just to reiterate, you can convince a developer to install a Python interpreter or a Java interpreter and all the required system dependencies to run a Python or a Java project, for example, but you can't ask that to a non-technical user. And that limits severely the range of users that your software can serve. And there's also a double shame. This is really also a double shame, because not only you don't get any benefit from virtualization, but you're also wasting a move that can actually come in really handy when, even in the present day. So the idea is you're already using a language that targets AVM right off the bat. You don't get any advantage from it, and you kind of lose the ability to opt into that idea later on. I mentioned earlier that that the Super HTML language server is available as a VS Code extension. The first iteration of that extension required you to install the extension and then also to download the CLI tool separately and to put it in path. And that's a lot of steps, which hurts with software distribution. But after Matthew Lag from the Z-Core team helped Microsoft finish their WASI implementation in VS Code, here you can see the PR, I can now bundle a WebAssembly build of the CLI tool directly into the extension. So I take my CLI tool, I build it for a virtual machine, because then that runs more, because then now users can run it in their VS Code, whether they're on Mac, Linux, or Windows. And now users only have to install the extension, and they don't have to do anything else. This is the current status quo. And so this is another example where, targeting a virtual machine does help with virtualization. There's another interesting story related to this, which has to do with the Z compiler. The Z compiler has a bootstrap system that is also goes through WebAssembly. I'm not going to get into that here on stage because it probably deserves its own talk. But if you happen to meet Andrew in the hallway later on, maybe ask him about that. It's very interesting. It's not the same as Pascal, but it's weirdly similar. So going back to the main topic. So why do we use primarily high-level languages? And I think there's obviously a plethora of perfectly legitimate reasons, like using JavaScript for web stuff or Python for data science. But when it comes to general-purpose software engineering, I think a major reason is that developers believe it is easier to write software in those languages than it is to write software in a low-level language. And there's definitely truth in that statement. There is no doubt that it is easier to get started with Python than it is with Zig. But if you're a professional software engineer and you're creating something non-trivial, which, put more bluntly, is what tends to happen when you don't limit yourself to gluing dependencies together, then it doesn't take long before the equation flips around. In Zine, page rendering is an embarrassingly parallel problem, and it was very straightforward for me to profile and optimize the behavior of my program, while it was not the case with Python, for example. And in a sense, it's kind of like the graph where you have Microsoft Word and LaTeX, where in the beginning, Microsoft Word, it's easier to use than LaTeX. But the moment you add one image to your document, the equation flips around, right? And so to recap, my advice to you is to learn a lower-level language like Zig, because the extra control that you get from them will not only be welcome, but even necessary when you decide to aim for high-quality experience for your users. Zine would have been a worse piece of software if I had chosen any higher-level programming language. I firmly believe this. To craft a high-quality experience, you need to reinvent the wheel. Not all the time. It is good to be able to depend on other people's code. But when it comes to the core features of your software, you need to have full control over the design. So if you find those ideas compelling and wonder how to get started, Systems Distributed is not a bad place to start. For example, you can come talk to me later on or find Andrew in the hallway. And another place where you can find more like-minded people is at a Zig Day. Zig Days are full-day in-person events that the Zig community has started organizing, where on a weekend day, you meet in the morning and you spend the entire day coding with other people with the explicit goal of improving your systems thinking and creating high-quality experiences for your users, which is what I more generally call creating software you can love. If you're interested, go to zig.day to learn more. Andrew runs a Zig Day chapter in Portland, Oregon, while you may find me at the Zig Day hosted in Milan, in Italy, for our fellow Europeans. And yeah, this is it. Thank you very much.